In this video, we will be using inscribed angles and their intercepted arcs, and inscribed polygons as well. So this is theorem 10.7, which is on page 672 of your textbook. What theorem 10.7 says is that we have the measure of an inscribed angle, that means inside, here's this angle, and that is equal to 1/2 the measure of its intercepted arc. So we will be using the measures of angles to find the measures of arcs, and the measures of arcs to find angles. So looking at this example, we have measure of angle QS is what we want to find, and then we also want to find the measure of angle RST. So we're going to find the measure of an angle and the measure of an arc. So if I were to fully write out my equations, the measure of angle QRS equals 1/2 the measure of arc QS, and I were to fill in my measurements, I would know 50 degrees equals 1/2 the measure of arc QS, multiply each side by 2, and the measure of arc QS equals 100 degrees, and that is what we are looking for, so 100 degrees. And then if we were to find the measure of angle RST, writing our full equation out, measure of angle RST equals 1/2 the measure of arc RT, filling in our values, that equals 1/2 times 48, which is equal to 24 degrees. Moving on to theorem 10.8, it says that if we have two inscribed angles, which here the measure of angle ADB is equal to the measure of angle ACB. If we have two congruent angles, then their corresponding arc is going to be congruent. Their corresponding arcs are going to be congruent. And conversely, if two angles have the same corresponding arc, which they both do, they have arc AB in common, then those angles are congruent. So we can use that piece of knowledge to easily set some values equal and find some missing measurements. Alright, in the next theorem, on page 674, theorem 10.9, discusses a right triangle. So we can have inscribed polygons, which means the polygon is circumscribed by a circle. So a circle will be going around a polygon, and each of the vertices lie on the circle. So this theorem says that if a right triangle, so we do know that it is a right triangle, if a right triangle is inscribed, then the hypotenuse is the diameter, which that's going to be an important piece of information. And conversely, if one side of an inscribed triangle is a diameter, then the opposite angle is a right angle, which they will be asking, alright, angle B, that's opposite of the diameter. And so angle B is going to be 90 degrees, and that will help us find some missing measurements in our next example. So in this example, we want to determine if AB is a diameter or not. Is there enough information given to us that we can figure it out? So first we just want to go ahead and look at the triangle. So we are given the measure of angle A in the triangle is 60. The measure of angle B is 30 degrees. So can I find the measure of angle C, because that's a piece of information that's going to help us? So we absolutely can. 180 minus the sum of 60 plus 30. So that's 180 minus 90 degrees, and our result is 90. So we do know that this missing angle is 90 degrees. And in the previous theorem, it was stated that if that angle opposite the hypotenuse was 90 degrees, that means the hypotenuse is a diameter. So yes, AB is a diameter, Alright. Moving on to the next theorem, theorem 10.10. It uses quadrilaterals. So if a quadrilateral is inscribed, so yet again that means that each and every vertex is located on a circle. If a quadrilateral is inscribed in a circle, its opposite angles are supplementary. And if the opposite angles are supplementary, that means a circle can be drawn around that figure. So, as far as supplementary goes, if I were to solve for x and solve for y using the following measurements, let's go ahead and say that this is about 100 degrees, and then this one looks to be about 90. Alright, so I know that x plus 90 has to equal 180, and y plus 100 has to equal 180 since it is inscribed. Therefore, x equals 90 and y equals 80. Alright, now if it were to ask, can this quadrilateral be inscribed? It would look like the following example. Alright, so examining this quadrilateral, we've got opposite angles must be supplementary, so if we add those two together, we get 185, and that already is a no-go. They are not supplementary. Therefore, this quadrilateral cannot be inscribed, so I couldn't draw a nice, perfect, pretty circle all the way around them. Alright, if you guys have any questions, please feel free to see me before or after school or send me an email.